This data set has a covered carport on the west, an entry courtyard, and then a living space with a large fireplace, and to the south a separating corridor where there are 3 bedrooms. The building was from Victor Olgyay, who created it as a design proposal for a competition that was based in Phoenix, Arizona. A major feature of the design was to use clerestory lighting and to provide louvers so that the daylighting requirements could be adjusted at different seasons. The feature in Revit that we can use to help us with our lighting studies is design options, where we can have different settings for the louvers according to, say, winter, summer, or fall and spring equinox, or just equinox. We'll be able to, in views, set the position of the sun and then choose our design option for which louvers we want to have. On the south side of the building, the roof and the side walls shade the facade of the bedroom areas. On the east side of the building, the step in the building shades the entry to the central corridor space. And you can see as the seasons change, the louvers are adjustable to control the daylight for the living space. The north side of the building has no openings to the interior of the building. Nevertheless, it might be useful to look at the shadow conditions in regard to any related outside activities. On the west side of the building, you can see the carport and the different shading that's available for different times of the year. And an entry from the carport and how that's shaded, and then on the roof an indication of how the louvers would be changed to meet conditions desirable for summer solstice, winter solstice, and kind of an average in the equinox. So that clerestory area is covered by these adjustable louvers. The form of the louvers, the angle of the louvers, all of that can be designed as needed, and then we can use them to test the interior lighting conditions. We can take a look at the central living space and the fireplace, and above it the clerestory lighting with the louvers. The floor was made of glass blocks, and there's a sunken seating area in front of the fireplace, indoor planters, and a large pool adjacent to the living room. The louvers can be adjusted here just for renderings, but we want to be able to measure light values inside this and adjacent spaces. In this virtual building, we can change the position of the louvers and measure values for illuminance. We can also carry out daylight analysis for LEED accreditation, and we can do some other studies with regard to illuminance on surfaces, for example on the south elevation of the building. There is an associated food preparation area or a kitchen that shares some of the light from this overhead clerestory. So we would want to be able to measure light levels, say on those countertops. The building is separated by a central corridor that's accessible here on the east side. So if we go outside the building, when we come in on this entrance, the bedrooms are on the left. We'll get a glimpse into the bedrooms. And then on our right hand side we have other utility rooms, WCs, bathrooms, those kind of things. So that's kind of the tour of the house, and we're now wanting to do studies where we get quantitative results for this interior space. So we need to get some quantitative results regarding the lighting. And examples of that would be that we can, say, look at the south elevation of our building and measure luminance on the surface of the building. This showing the carport on the left and the bedrooms on the right. And we can measure that at different times of the year and get a color readout for a measure of the foot candles on those surfaces. So if we actually want something quantitative, we can conduct a study. Say we're looking for 75 foot candles in the kitchen area on the countertops, or 30 foot candles as a general measure inside the building. We can create views for any time of year with different louver conditions, and we can produce output that lets us see whether we come any place close to meeting our goals. This would help us shape the design, change the design as we're working on it. We might also be doing this in other areas of the world where we want to have, say, measures in lux. So, say 750 lux, or 300 foot candles. We can run those kind of studies and then review the end results to see if we're actually close to meeting the design goals that we set for ourselves.